our solutions for the symmetry problem for this week. So for the horizontal line of symmetry for the first problem, got this horizontal line, and we'll keep that in mind as we do our colorings. So we wanted to be able to flip across that line, but not across any diagonal or any vertical lines. So we have this one and this one that would flip, this one and that one. You can see that this flips horizontally, but not vertically. We also have, if you color, an entire side. And we also have this interesting one, which sort of combines the first two, but just on different sides. And then, since we're not counting inverses, but we could count vertical reflections, we can do the same thing as the first two, but just on the other side. So you have a total of 6 possible different ways that we color this so that it has a horizontal line of symmetry, but no diagonals and no verticals. Then if we're looking at a right sloping diagonal, we can see that we can color these two, and flipping that across will make symmetry. These two, we can also color an entire sort of like top half or side kind of thing. We could do this one and this one. We could do this one and that one. And we have one more option, which, like this one, sort of combines 2 of these together. So this one and then these 2. And you can see that one still flips across this line, and the inverse would be the same thing on the other side. Looking at both the horizontal and vertical axes, but no diagonal. So it needs to be able to flip across both the horizontal way and the vertical way, but not the diagonal way. You know, if we colored in the whole thing, obviously we'd be able to flip all of the ways, so we can't do that. So we have to be selective about which ones we're picking. So let's look at some of the ones that work for horizontal flipping. So we've got this one and this one, which hold some promise because you can see they don't flip diagonal. So what if we take this and flip it across vertically? Then we know that this has vertical symmetry and it has horizontal symmetry. And if we check, if we try to flip it across this diagonal, these don't line up and these don't line up. So this would work. Are there any other solutions? Well, let's try. So we look at all the ones that have only horizontal symmetry and we flip them across so that they match. This is the only one that is a unique solution. So if we did this one, it would be these 2 and these 2, but this is the same thing because these are inverses of each other. So that's the same solution. And if we did this one, it would color in the whole square, which has diagonal symmetry, and we don't want that. Same thing with this one. And then these would also get you these 2 patterns again. So there's only one solution for the third problem. So our final problem deals with rotational symmetry. Rotating the square around less than 360 degrees, but still looking the exact same. I think the easiest one to start with is 180 degree symmetry. So if it has, for example, these 2 colored in and these 2 colored in, you can see that if I turned this 180 degrees, it would be the same. And so we can do the same thing with just 2 of the segments, either those 2 or these 2. And we could also do the same thing with these top 2 and these bottom 2. So with rotational symmetry, you definitely have to be careful about inverses, because you can see you might be tempted to do, for example, this and this. That's also rotationally symmetric, but that's the same thing as this one. And with these, this coloring, if I colored in 3 on each side, would be the same as this one. We also need to remember that since this is a square, there's some potential for 90 degree rotational symmetry. For this, if we color in, say, this one, if we color in every other segment, then we end up with being able to rotate it 90 degrees, 180, and 270, and all of those being the exact same picture.